Now in this section, we're going to go over word problems, but we're going to be able to use two sets of equations to solve them, and then using the techniques we had in previous sections. So as we do a word problem, write out or read the problem carefully a number of times, and then write your equations. Now, by getting the correct equations, you can earn partial credit. And then, of course, you want to try for the proper solution. And we didn't put the hardest ones on the test, so you ought to be able to do it. Now, up over here on the right, there is a little link where if you click on it, it goes to the additional exercises that I've done, where I do many problems if you'd like to have that extra practice. All right, so let's get started on this. One number is 5 less than a second number. And since you are allowed to use two equations, we'll have the one number be x is 5 less than a second number. Well, the second number is y and 5 less. So there's your first equation. Now, twice the second number, which we'll designate as y, twice the second number is 5 less than 5 times the first. Well, 5 times the first would be this, less 2. So what we should do is, again, if I were the student, pause, reflect, and see if these equations are good. And they are. Now, the next thing is you decide what technique might you use to solve these. Well, it's sort of obvious, because we have x as something, so I would suggest substitution. So where there's an x, you put that value. And we'll do substitution for this. And I'll give you a chance to work it out as well. So, something like this. We distribute the 5, get this line, collect like terms. This is going to be a negative 27. Transpose the 5y to this side, get a negative 3y. Divide both sides by a negative 3, and we get a positive 9. So one of the numbers, and it happens to be the y value, is 9. Now, if y is 9, you can put it right there. 9 minus 5 is 4. Now, often in these word problems, they don't want it as an ordered pair. They might say, what's the smaller number, what's the larger number, or list the numbers and separate them with a comma. You don't necessarily need the parentheses. So this one wasn't too bad. Let's go on. Now, as we read this, let's see if we can put what's here into some sort of diagram. We have two trucks heading in the same direction. The slower truck has traveled 301 miles. The faster truck also traveled that 301 miles, but was 56 miles beyond that truck in 7 hours. So what we don't know here is what was the rate of speed. So we could use distance formula, and in a sense set it up as two separate equations. For this one, it's going to be the total distance is 357 equals its rate times the time, which is 7 hours, and this other fella, distance equals rate times time, is 301. Its rate times 7 hours. So when we solve for the letter R here, we just divide both sides by 7. We get this is 51. And when we divide this one by 7, we get the slower truck is 43. And I wasn't able to set this up using the two equations, so I'm not quite sure why they gave us this problem here, but that's what's there. Again, we'll take a look at some of the others. I think I have a worksheet that I'm going to give you for some of these. To give a little background on what's going on here, we're looking at cost function and revenue function. When I was in high school, I was a member of a group called the Junior Achievement Program, where we would produce a product after selling stock, and then we would sell the product, we'll make it, sell it, and then pay off our shareholders. So if you've heard of junior achievement companies, that's, I don't know, they might still be happening somewhere. But this was back in the 50s, a long time ago. So anyway, they're saying that in order to make something, as we see here, there's certain cost. Now, the way they set it up, this part is the fixed cost. If you were going to produce a certain product and you had like a machine that you had to buy, that would be your fixed cost. And then as you produced a particular item, to make that item, there were material costs just for that. And that was $95, let's say. And then the machine you used was this, just as an example. Now, when you sold the product, that would bring in revenue. And that would be a certain price that you would sell that product for. And here you would sell it for $105 per item. Here again, fixed cost, materials cost to produce the item, and then for revenue, when you sold the item, you sold it for this. Now, if we made a graph of this, this would be our R of X, our revenue line. We didn't sell any, we start at 0, and as we sell it, the amount goes up. And then this is our cost. We have a certain fixed cost, that would be the $1,100, and then we have materials that as we sell them, or produce them, I should say, $95 worth of stuff. So this is just an example, it's not to proportion, but you notice that these lines do intersect. And at this point of intersection, what is the significance of that? Well, that is what we call the break-even point. Once you sell this number of products, above it is a profit area. But this point right here is your break-even. So you want to solve this set of linear equations for where they intersect. Now we had said we could substitute the function notation with the letter y. So in a sense, we're saying here that this y equals this y. So our equation for this is set up by taking 95x plus 1100 equals 105x. Just taking these two equations, these parts of them, and equaling them to each other. And that's what we'll do here as well. So here we subtract 95 from both sides, and we get 10x equals 1100. Divide both sides by 10. We get x equals 110. So the break-even point for 2a is you need to sell 110 units to break even. So this number right over here would be 110. Okay, let's do the next one. This is done the same way, where we're going to substitute a y and a y for our function and equal each part of the equation to each other. We're going to subtract 0.3 from both sides, and here we end up with 1400. Now once again, what does that refer to? The number of units that you would have to sell in order to break even. Alright, now the next one will be a little bit more involved, but similar. So take a moment to read it carefully, or a few moments, and see if we can come up with the cost equation and the revenue equation to start us off. So hopefully you have something like this. This would be your fixed cost, and this is what it costs to produce a particular item, the immediate materials. So again, we can change this to a y and this to a y, and we have y equals y. So we have 0.50x plus 1000 equals 300x. Now you could leave the decimals or you could get rid of them. That's okay. We're just going to do a little subtraction here. And we divide both sides by 2.5, and we get x equals 400. And what does the 400 stand for? Well, it's the number of packages that must be sold for the company to break even. Now, we'll take a little time to work on the additional exercises because these are really too few problems, and we'll do that until the end of class.